Good afternoon, class. My name is Miss Goma, teaching you Integrated Science Grade 8. Okay, so last week we started the topic which was materials, and last week we learned about mass. We defined mass. We said mass is the amount of matter in an object, and we also defined what matter was. We said matter is anything that occupies space and has weight. Okay, apart from that, we learned the standard units for mass, where we talked about kgs, kilograms, milligrams, and tons. Apart from that, we also learned on the instruments that are used to measure mass. Class, what were the instruments that you learned last week that are used to measure mass? Can anyone give me the answer of any instruments that you can use to measure mass? Okay, good. Okay, we said that the beam balance is an instrument that is used to measure mass. A weighing balance is also an instrument that is used to weigh mass. Okay, so that's what we learned last week. In today's lesson, we're going to learn on weight. Are we together, class? We're still on the same topic, which is materials. Okay, so under materials, we're going to learn weight. Okay, so before we go any further, we need to define what weight is, class. Okay, we need to define what weight is. Class, what is weight? In your own understanding, what is weight? Okay, so weight is a pull of gravity on a mass of an object. Weight is a pull of gravity on a mass of an object. Okay, so I'm defining weight to be the pull of gravity, on a mass of an object, class. Okay, so I'm defining weight to be the pull of gravity on a mass of an object. Okay, because last week we defined what mass was, and we said mass is the amount of matter in a substance. Are we together, class? So after defining weight, we need to know what instruments are used to measure weight. Are we together, class? We need to know what instruments are used to measure this weight. What instruments are used to measure weight? Okay, so the first instrument, we have a meter rule. A meter rule. Okay, so a meter rule is an instrument that is used to measure weight. Apart from a meter rule, which other instrument can you use to measure weight, class? Apart from a meter rule, which other instruments can be used to measure what? Weight. Okay, another instrument that we can use to measure weight is a spring balance. Okay, a spring balance. Are we together, class? So how many instruments have I given you that we use to measure weight? How many instruments? 2 instruments. The first instrument that we can use to measure weight is a meter rule. The second instrument that we can use to measure weight is what? A spring balance. Okay, so these are the 2 instruments that we can use to measure what? Weight. Having learned that we've defined weight to be the pull of gravity on a mass of an object, and the 2 instruments that are used to measure weight, what are the standard units, or what are the SI units for weight, class? What are the standard units for weight? Okay, class, what are the standard units for weight, or what are the SI units for weight? Okay, so the SI units or standard units for weight are newtons. Okay, so the standard units for weight are newtons. Okay, and they're denoted by the capital letter N. Okay, so the symbol for newtons is capital letter N. Are we together, class? Okay, so we're saying the standard units for weight are newtons, and they're denoted by the symbol capital letter N. Are we together, class? Okay, having defined weight, having looked at the instruments that we use to measure weight, and having looked at the standard units for weight, how do we calculate weight given their mass? How do we calculate weight given their mass? Okay, so let us look at these examples. calculating weight given its mass, okay? So let us look at examples on how you calculate weight when you're given its mass, okay? So the first example that I have here is calculate the weight of an object, example 1, okay? Examples, okay? So I have a lot of examples, but for today I'll only give you how many? 3 examples on how to calculate weight, okay? So the first example reads, calculate the weight of an object. Calculate the weight of an object whose mass is 25 grams, whose mass is 25 kgs, okay? Given acceleration due to gravity 10 newtons per kg. Okay, so they're saying calculate the weight of an object whose mass is 25 kg given acceleration due to gravity is 10 newtons per kg. Are we together, class? Okay, so what do we do when you're given such a question, class? What do we do when you're given such a question? Okay, so what you do is you collect the data. What you do is to collect the data. Okay, so write data down here. So calculate the weight of an object whose mass is what? What's the mass have we been given? A 25 kg. Our mass is what? Mass M is equals to 25 kgs. Okay. Given acceleration due to gravity is equals to 10 newtons per kg. What are we looking for? We're looking for the weight because they're saying calculate the weight of an object. So weight is equals to question mark. Because we do not know the weight. We want to calculate the weight, okay? So after you've collected the data or the information that you've been given in the question, you go to your formula. What is the formula you use when you want to calculate weight, class? What is the formula you use when you want to calculate weight, class? Anyone to give it a try? Okay, so the formula to calculate weight is weight is equals to, okay, we need space, okay. So say this is a formula for calculating weight. So say weight is equals to mass times acceleration due to gravity. Acceleration due to gravity, okay? Because we've defined weight to say weight is a pull of gravity on a mass of an object. So it's dealing with gravity and it's also dealing with mass. Are we together, class? So having collected the data or the information where mass is equals to 25 kg, acceleration due to gravity is equals to 10 newtons per kg, weight is equals to question mark. Because we want to find mass, we want to find weight, we don't know what weight is, okay? So our formula for calculating weight is equals to mass times acceleration due to gravity. So we need to place in the values that we've been given here, okay? So we'll say weight is equals to, what is our mass, class? Looking at the data that we've been given. What is our mass, class? Looking at the data we've been given, okay? So our mass is 25 kg, okay? Then our acceleration due to gravity is times 10 newtons per kg, okay? When you look at this information you've been given, you look at the SI units. Do they match? Class, do the SI units match? So on the mass we have kgs here, and on the acceleration due to gravity we have what? kgs here. So meaning we'll go directly in calculating because the SI units match. Because for mass we have kgs, acceleration due to gravity we also have kgs this side. Are we together? So we're dealing with weight, and we said the SI units for weight or the standard units for weight are newtons, and we have newtons here denoted by capital letter N. So we'll go direct in calculating. That's why I've said weight is equal to 25 kg times 10 newtons per kg. What is our answer, class? Can anyone give us our answer? Okay, so our answer is 250. 250. When you multiply 25 kg times 10 newtons per kg, you're going to have 250. But what SI units are we looking for? What SI units are we looking for? Because we've said weight, its SI units are newtons, okay? So this kg will cancel, it will go. And this other kg this side will cancel, it will go. What are we remaining with? We are remaining with the newtons. So our SI unit is newtons, and our answer is 250 newtons. Any questions, class? Any questions, okay? Let's go to example 2. Let's go to example 2, okay? Example 2 reads, a car has a mass of 600 kg. A car has a mass of 600 kg, okay? So a car has a mass of 600 kg. What is its weight? What is its weight, class? Okay? Given acceleration due to gravity, 10 newtons per kg. So what's the first thing you do when you look at this question? So you read the question. After reading the question, you collect the data or you collect the information that has been given in your question, okay? So we'll say data, we'll write it here. Okay, so a car has a mass of 600 kgs, okay? So our mass is equals to 600 kg. What is its weight? So they're looking for the what? For the weight, okay? So weight is equals to question mark. We don't know. Given acceleration due to gravity, 10 newtons per kg. Okay, so acceleration due to gravity is equals to 10 newtons per kg. Okay, let's go to our formula. What's the formula for weight? What's the formula for weight, class? At least we've had the first example, so this one will not give us problems. What's the formula for weight? Okay, so the formula for weight is equals to mass times acceleration due to gravity, okay? So let's look at the information or the data we've collected, okay? When you look at the SI units, do they match? Let's go together. Mass, our SI unit is what? Kg. Then when we come to acceleration due to gravity, we have kgs here. So meaning we have kgs, which is correct. They're matching. And when you look at the N is newtons. So this will go direct in what? In calculating, okay? Just placing in the values. So say W, which is weight, is equals to, what's our mass? Our mass is 600 kg times, okay? Acceleration due to gravity is 10 newtons per kg. Okay? W. So 600 kg times 10 newtons per kg. What is the answer, class? Okay, so our answer is 6,000. Our answer is how? 6,000. How many zeros do we have? 1, 2, 3, okay? 1, 2, 3. Meaning our answer is what? 6,000. What SI units are we using? Are we using kgs? Are we using newtons? Let's go back to our calculation there, okay? So we have the kgs these kgs will cancel because in this side we have what? Kgs. What are we remaining with? We are remaining with what? Newtons. And newtons, these are SI units for weight. So our answer, weight is equals to 6,000 newtons. Are we together, class? So that is our answer for the next example. Can you go to the last example for today? Okay. So the third example is, what does it say? It says, what is the weight of a pencil? What is the weight of a pencil? Okay, so what is the weight of a pencil? What is the weight of a pencil whose mass is 20 grams? Whose mass is 20 grams. Okay? Given acceleration due to gravity 10 newtons per kg. Okay? Can we use the first part of the board to calculate that one? Okay, hope you've written down for this and hope we're moving together. No one is lacking behind. Okay. So what are we supposed to do when you're given such a question? Because at least we've had example 1, example 2. Now we're dealing with example 3, okay? The question reads, what is the weight of a pencil whose mass is 20 grams? Given acceleration due to gravity 10 newtons per kg. So we collect our data, we write data here, data, okay? So data is the information that we've been given in the question. So we say, what is the weight of the pencil whose mass is 20 grams? Our mass is what? 20 grams. Mass is equals to 20 grams. Are we together, class? Then, given acceleration due to gravity, which is 10 newtons per kg. So acceleration due to gravity is equals to 10 newtons per kg. And what are we looking for? What is the weight? Okay? What is the weight? Weight is equals to x. We do not know. That's what we want to find. Okay? So, the formula for weight, we already know it and we've learned. We're saying weight is equals to mass times acceleration due to gravity. Okay? So, W stands for weight, M stands for mass, A stands for acceleration due to gravity. Okay? Let's go back to our data or the information that we've been given in our third question. Okay? So, when you look at the SI units, okay? There's a gram here, there are grams here, and there are kgs here. So these are different SI units. We learned when we just started this topic to say kgs are bigger than grams, okay? So these are different SI units, but they are both used for mass. Are we together? So when you're given two different SI units, you need to convert the grams into kgs. Are we together, class? And we learned on how to convert different types of SI units. Are we together? So if you're given such a question, meaning we cannot go direct putting these values in the formula. We need to do what? To convert the grams into kgs. Okay? And we said 1 kg is equals to 1,000 grams. That's what we learned when we started this topic. Okay? So we're saying 1 kg is equals to 1,000 grams. Okay? Where is our gram? We have a 20 gram there. So the 20 gram will fall under grams. Okay? So put our 20 grams this side. Then this side it is x. We do not know because we're converting the 20 grams into what? Into kgs. Are we together, class? Okay? So we'll cross multiply. 1 kg times, so say 1 kg times 20 grams equals to, then 1,000 grams times x. Okay, so 1 kg times 20 grams will have 20 grams per kg equals to 1,000 grams times x will have 1,000 grams x. Okay, for us to remain with the x, we divide both sides by 1,000 grams. 1,000 grams. Okay, that 1,000 gram goes, that one goes, I'm remaining with an x side. Okay, Then this gram will go, the other gram will go. Okay, so I'm remaining with kgs there. So say 20 kgs into 1000. It can't, okay? So put a 0 point. The moment I'm putting a point here, I'll add another 0 here. What about 200 into 1000? It still can't. 200 is smaller than 1000. So we'll put another 0 here. The moment I'm putting a 0 here, I'm adding another 0 here. What about 2000 divided by 1000? Okay, my answer is 2. Are we together, class? Okay, then the SI units, are they bananas, mangoes? We are supposed to know what we're calculating. Okay, so I remained with kgs here. So I'll bring my kgs down here. So we've converted the 20 grams into kgs, and our answer is 0.02 kgs. So this is the mass we're going to use. Okay, so now we'll say weight is equals to mass times acceleration. What is our mass? We're going to use a 0.02 kgs times 10 newtons per kg. Okay, so are we together, class? When you look at these SI units, they're now matching. We have kgs this side and we have kgs this side, and the newtons will use it for weight. Okay, so these kgs will go, the other kgs will go. Okay, what about 0.02 times 10 newtons? Okay, so our weight is equals to 0.2 newtons. Is there anything hard here? There's nothing that's hard. Are we together? So our answer, or the weight that we found, is 0.2 newtons. Are we together, class? Okay? Okay? Okay, so apart from now that you've learned on how to calculate weight, what are the differences between weight and mass? What are the differences between weight and mass? Okay, so let us look at the differences. Hope we've written this. Let us look at the differences between weight and mass. Okay, let us look at the differences between weight and mass. Okay, so these are the differences. That's a table that demarcates weight and the mass. Okay, so we have mass this side and we have weight this side. Okay, so what are the differences between mass and weight? So you can differentiate the two by their definition. You can differentiate the two by their definition, by their SI units or standard units, by the instruments that they use. Okay, so let's go. The difference between mass and weight is that 1. Mass is the amount of matter in a substance. Then weight is the pull of gravity on a mass of an object. Okay, so that's the first difference. Mass is the amount of matter in a substance, and weight is the pull of gravity on a mass of an object. Okay, then the SI units for mass are kgs, grams, milligrams, and tons. Okay, then the SI units for weight are newtons. SI units for weight are newtons, like that. Okay, so we've differentiated by their definitions, and we've also differentiated by their SI units. Okay, then the other thing is that mass is measured, or the instruments that are used to measure mass: 1, beam balance. So we're differentiating by instruments: beam balance, weighing balance. Okay, then weight, the instruments that are used to measure weight, we said are spring balance. Apart from the spring balance, we also talked about the meter rule. meter row. Then the last one, at least the fourth one. So mass is constant. Mass is constant. Then weight varies from place to place. Weight varies from place to place. Are we together, class? Okay, so these are the differences between mass and weight. So if given the differences according to that definition, because mass is the amount of matter in a substance, while weight is a pull of gravity on a mass of an object. Then we've also differentiated by their SI units. The SI units for mass are kilograms, milligrams, grams, and tons. Then weight, SI units are newtons, denoted by capital letter N. Okay? Then we've also said the instruments that are used to measure mass are beam balance, weighing balance, even triple balance. Okay? Then this side, on the weight side, we've said the instruments that are used to measure weight are spring balance, meter rule. Are we together, class? Then the last one that I've given is that mass is constant. It does not move from place to place. But weight varies from place to place. Are we together, class? So we have no problems on how to calculate weight. We have no problems on how you differentiate weight and mass. Are we together, class? The next time we meet, we'll learn on density. Are we together, class? The next time we meet, we'll learn on what? Density. So the next time I come, I'll give you an exercise to see if you've understood today's lesson. Enjoy the rest of your lesson. Thank you.